So in the first lecture, we looked at some few definitions. These definitions included engine speed, engine torque, engine load, compression ratio, air-fuel ratio, stoichiometric air-fuel ratio, what is lean mixture, what is rich mixture, what is fuel-air ratio, and what is equivalence ratio. Then we solved this one sample sum on this. So after this, we will be looking at what are the different types of powers which are produced inside the engine. Okay, so see, to understand this concept, see, it is very simple. First of all, let me say there will be four powers. Okay, there will be four powers which we will be learning about. What are the four powers? You can see these powers over here. So first is the thermal power, second is indicated power, third is friction power, and fourth is brake power. These are the four powers which are concerned with your engine. So what are basically these four powers? See, it is a very simple concept. What is happening in an engine? In an engine, let us say this is your engine. Okay, you have an engine over here. What are you doing? You are putting in fuel. You are putting in fuel, right? It can be diesel, it can be petrol. This fuel burns inside the engine. Because of the burning of fuel, some amount of power is developed inside the combustion chamber. This power produced in the combustion chamber is transmitted to what? It is transmitted to your crankshaft, and from this crankshaft you get your output power. So what all is happening? Fuel is getting burnt inside the engine. Whatever is the amount of energy produced because of the burning of the fuel, some part of the engine some part of that power is used to produce work, and some part of that power combustion after the burning of fuel, some amount of heat energy is lost. See, I am putting fuel into the engine, that fuel is burning, some amount of heat energy is lost, right? It is lost to coolant, it is lost to exhaust gases. Some amount of that power is converted into actual work inside the engine. Then the because of the movement of piston, the crankshaft starts rotating, and this rotation of crankshaft is your output power. So these are the various powers which are produced inside the engine. Okay, we will look at them one by one. First is what? Thermal power. Thermal power is what? Thermal power is the total energy released due to the combustion of fuel. Okay, it is the total amount of energy released per second due to the combustion of fuel. कि फ्यूल जब जलता है इंजन के अंदर, तो फ्यूल जलने की वजह से एक सेकेंड में कितना पावर प्रोड्यूस होता है, एक सेकेंड में कितना एनर्जी प्रोड्यूस होता है, उसको बोलते हैं थर्मल पावर. सो बिकॉज ऑफ द कंबशन ऑफ फ्यूल, व्हाट इज द अमाउंट ऑफ एनर्जी प्रोड्यूस्ड इनसाइड द इंजन पर सेकेंड, that is your thermal power, right? How is thermal power calculated? Thermal power is calculated by measuring what is the mass flow rate of fuel. What is how much fuel is being consumed in 1 second, and multiplying that fuel flow rate with the calorific value of the fuel. You will look at this afterwards, but that is how thermal power is calculated. Okay. After thermal power, there is indicated power. As I said, when combustion takes place inside the engine, not all the combustion power is converted into mechanical power. What happens? This is my engine, fuel is burning inside my engine. Okay, this is my combustion chamber, fuel is burning inside the combustion chamber. Some of that combustion chamber's thermal energy, it is lost to coolant, it is lost to exhaust gases, it is lost to radiation. Okay, and only some amount of power is used to move the piston downwards. This amount of power which is used to move the piston downwards is known as indicated power. Okay, so what is indicated power? Indicated power is the actual amount of power which is developed inside the combustion chamber. Okay, so indicated power is the actual amount of useful power which is developed inside the combustion chamber. That is the indicated power. How is the indicated power measured? See, if you have, let us say you are working with petrol engine, so it is an Otto cycle. Now we know when we have a PV graph, the work done is equal to area under the graph. So by measuring the area under the PV graph, we can calculate the indicated power. So what do? We have to calculate this area under the curve. So first we must draw this curve. So to draw this curve, we use this mechanism. This is known as indicator mechanism. What is happening inside? See, below this is your combustion chamber. Whatever is the pressure in the combustion chamber, that pressure is drawing a curve. At the end of this, over here there is a pencil. Okay, and this thing is rotating. This is a paper, and because on this paper is rotating on this, right? As the piston is moving up and down, this thing is rotating. So the PV diagram is drawn on this, right? And after the PV diagram is drawn on this, we can remove this paper, put it flat, and using that we can plot the PV diagram. And after plotting the PV diagram, we can calculate the area under the PV diagram. So that is the indicated power. Okay, no one is going to ask you how indicated power is calculated. You just have to remember the definition. What is the definition? That indicated power is defined as the amount of power developed inside the combustion chamber. Whenever fuel burns, it produces a lot of energy, that is thermal power. But all of that power cannot be used by the engine. Whatever is the amount of power that can be used by the engine to move the piston, that is known as the indicated power. Okay, so how is indicated power measured? It was measured using this thing. Okay, this was known as indicator mechanism. But nowadays we use pressure sensors and angular position sensors to know the P and V. Okay, and that is how we measure the indicated power. Next thing that we are measuring is the brake power. So what is brake power? Brake power, in simple terms, it is the most important power that we are going to measure of the engine. Brake power is the final output power of the engine. Okay, what is brake power? Brake power is the final output power of the engine. The final total amount of power produced in the engine's combustion chamber is indicated power, right? Whatever amount of power is produced inside the combustion chamber, that is the indicated power. But all this power which is produced inside these combustion chambers, what is happening inside combustion chamber? The piston is moving up and down. There is friction between the piston rings and the wall. Then there is a crankshaft which is rotating inside this crankcase. As the crankshaft is rotating inside the crankcase, there is some amount of friction between the crankshaft and the housing. So there is some amount of power which is lost between the cylinder and the crankshaft. Okay, there is some amount of power lost between the cylinder and the crankshaft. This, whatever the amount of power is lost, is known as friction power. Okay, what is friction power? Friction power is the amount of power which is lost between the cylinder and the crankshaft. And whatever is the final output power from the crankshaft is known as the brake power. Whatever is the final output power from the engine crankshaft is known as the brake power. As an engineer, if you are developing the car part of your vehicle, you are not developing the engine. If you are only developing the car part, then you are only interested in the brake power of the engine. Okay, how much power is produced by the engine, right? What is the final output of the engine? So brake power is the final output power of the engine, which is measured at the crankshaft. What is the friction power? Friction power is the amount of power lost between the cylinder and the crankshaft. Okay, friction power is also defined as the difference between the indicated power and your brake power. So these are the four different kinds of powers. What are the four different kinds of powers? Thermal power. Thermal power is the amount of power released due to the combustion of the fuel. Indicated power is the useful part of the indicated power. which is used actually for the movement of the piston. Frictional power is the amount of power lost between the between the combustion chamber and the crankshaft. And the final output power of the engine, which is measured at the crankshaft, is known as the brake power. Okay, so these are the four terms, right? And over here, as I said, how do you measure the thermal power? You measure the thermal power as mass flow rate of fuel into calorific value of fuel. So what exactly is calorific value of fuel? See, there are several different kinds of fuel. You have petrol, you have diesel, you have gaslit, you have kerosene, you have paraffin, you have bitumen, right? There are various types of fuels. But how can we categorize which fuel gives you more amount of energy, right? Which fuel on burning will give you more amount of energy? That is done by this term, calorific value of fuel. So what exactly is calorific value of fuel? Calorific value of fuel is defined as the amount of power developed by the fuel, amount of heat energy released by the fuel on combustion of unit mass of fuel. In simple terms, the calorific value of fuel is the amount of heat energy released by the fuel when you burn unit mass of that fuel. मतलब क्या, 1 किलो अगर पेट्रोल जलाया तो अपने को कितना अमाउंट ऑफ हीट एनर्जी मिलेगा, दैट इज द कैलोरिफिक वैल्यू ऑफ पेट्रोल. ओके, what is the amount of heat energy that you will get on burning 1 kg of diesel? That will be the calorific value of diesel. So thermal power is what? It is mass flow rate of fuel. In 1 second, how much amount of fuel is flowing inside the engine multiplied by the calorific value of that fuel. So that is your thermal power. Then indicated power is the amount of energy developed inside the combustion chamber in 1 second. Brake power is what? Brake power is the final output power of the engine. And frictional power is what? Frictional power is the amount of power which is lost between the engine combustion chamber and the engine crankshaft. Okay, so frictional power is the difference between indicated power and brake power, right? So based on these definitions, can also know how we can calculate brake power. Okay, see, it is very important to know how to calculate brake power. I will just go through this very quickly. It is okay if you don't understand this right now, but just take a look at how this thing works, right? See, what is power? What is the definition of power? Power is work done divided by time, right? That is the definition of power. Power is the rate of doing work, right? What is the definition of work? Definition of work is force into displacement upon time. Sorry, definition of work is what? Force into displacement. Power is what? Power is work upon time, and work itself is force into displacement. So what is the definition of power? Force into displacement upon time. I can write it how? I can write it like this: force into displacement upon time. What is displacement upon time? Velocity. So what is the definition of power? How can you measure power? Well, you can measure power as what? Force into velocity. But what is this definition for? This definition is for linear bodies. If the body is moving in a straight line. But in our case, our engine is not moving in a straight line. Our engine is what? Rotating. Our engine crankshaft is rotating. So we have to convert this linear into rotational. So what is the rotational equivalent of force? Rotational equivalent of force is torque. And what is the rotational equivalent of velocity? Angular velocity. So the formula of power is what? Formula of power is torque into angular velocity. Always remember, power is what? Torque into omega. Okay, torque into angular velocity. And what is the definition of angular velocity? Omega is 2 pi n upon 60. So what is the definition of brake power? Brake power's definition is torque into omega, 2 pi n upon 60 into torque. Okay, what will be torque? Tau. See, the initial definition that we had seen, if you remember, What is tau? Tau is the engine torque. What is tau? Tau is the engine torque. And what is n? In the 2 pi n upon 60, what is n? Engine speed. That is why these two definitions are important. Okay. From here, you can understand that how the brake power of an engine is calculated. What is the final output power of the engine? So that is your brake power. Another definition, another important definition of brake power is what? Brake power can also be calculated by using BMEP. Okay, BMEP is what? Brake mean effective pressure. This has already been explained to in module number 3 and module number 4, right? Brake mean effective pressure is what? Brake mean effective pressure is the average amount of pressure which when applied on the piston will produce the same amount of work as is produced in one cycle. Okay, so you have to look into module number 3 and 4 for this definition. Okay, so basically over here I have given the complete definition of your complete derivation of brake power, but in the end you can always go and look at this because I have explained this entire thing beforehand. That is why I'm not going into details right now, but the main formula for brake power is this. Okay, this is the main formula for your brake power. How are you going to remember it? Brake power. See, there are two formulas for brake power. What is the first formula for brake power? Brake power is equal to 2 pi n upon 60 into torque. Okay, 2 pi nt upon 60. This is the first definition of brake power. What is the second definition of, what is the second formula for brake power? Second formula for brake power is this: Planck upon 60 into number of cylinders. Okay, Planck upon 60 into number of cylinders. Where what is each term mean? P means brake mean effective pressure. L means your stroke length. Okay, this is your piston, this is your top dead center, this is your bottom dead center. This is your stroke length. A is what? Cylinder area. Okay, so area of this cylinder, that is A. What is N? Engine speed in RPM. And what is K? K is a constant. For 4-stroke engine it is 0.5. For 2-stroke engine K is 1. Why is this? Because for a 4-stroke engine there are 2 rotations of the crankshaft for one cycle. 2 rotations of crankshaft for one cycle. Hence brake power is what? Planck upon 60. Okay, so in the end you have to remember two things. Brake power has two formulas: tau into omega 2 pi nt upon 60, or else second formula is Planck upon 60 into number of cylinders. Okay, and this is again the definition of brake mean effective pressure. Okay, see what is brake mean effective pressure? Brake mean effective pressure, as I had told you beforehand only, brake mean effective pressure is what? The average pressure which when applied on top of the piston head will produce the same power output as the engine is currently producing. See, what does this mean? What does this actually mean? Okay, see, this is your Otto cycle. What is happening in your Otto cycle? As the piston is moving up and down, the pressure is changing. See, here the pressure is increasing, again increasing, then decreasing, decreasing, again increasing. So basically as the piston is moving up and down, the pressure keeps on changing. What is the total amount of work done in this entire cycle? It is the area under this curve, right? What is the total amount of work done in a cycle? It is area under the curve. So in this case, what can we do? Rather than showing it like this, okay, this odd curve, we can do a simple thing. What can we do? We can draw another PV diagram, and in this diagram what are we going to do? We are going to keep the swept volume same. We are going to keep the swept volume same. But what are we going to do? We are going to make the pressure such that it is a flat line. This pressure is constant. Okay, let me explain it to you once again. We are going to draw another PV graph. Another PV graph will be drawn. This is another PV graph. Here we are going to keep the swept volume same. These are same as these two. Then we are going to draw a rectangle over here such that the area of this rectangle is equal to this area. Area of my rectangle is equal to area under this curve. So what does that mean? What is the area under this curve mean? Area under the curve means the amount of work done. If area under this curve and area under this curve are both equal, what is that meaning? Means the work done in both these situations is same. But in this case, what is happening? The pressure is varying continuously. But in this case, the pressure has been kept constant. So what is break mean effective pressure? Break mean effective pressure is just a simple way of defining what is the amount of power produced by the engine. Okay, it is a simple method to calculate the amount of power produced by the engine independent of the swept area. Okay, so that is what break mean effective pressure is. What is the main thing that you have to remember? See, even if you don't remember this entire definition, you just have to remember this thing. Break mean effective pressure is what? It is the brake power developed in one cycle. The brake power developed in one cycle divided by the swept volume. Okay. What is brake mean effective pressure? Brake mean effective pressure is the brake power developed in one cycle divided by swept volume. And similarly, what is indicated mean effective pressure? It is indicated power developed in one cycle divided by swept volume. So see over here, when we are calculating this area, what exactly are we calculating? This area is what? This area is indicated power. Remember, this area is indicated power. When we calculate this area, we are calculating indicated power, and when we divide it by the swept volume, we are going to get indicated mean effective pressure. Okay, and similar to this, we can also calculate brake mean effective pressure as what? Brake power developed in one cycle divided by the swept volume. Okay. After brake mean effective pressure, the next important term that we have to see is brake specific fuel consumption. So brakes, I have explained this to you in module 3 and module 4 also. Still I will explain it to you again. What is brake specific fuel consumption? Brake specific fuel consumption is, in simple words, rate of fuel consumption divided by brake power. Okay, mass flow rate of fuel divided by brake power. So what is the unit for brake specific fuel consumption? Unit for brake specific fuel consumption is kg per kilowatt hour. How do we get that? Unit? It is mass flow rate is calculated in kg per hour, and engine brake power is calculated in kilowatt. Okay. What is brake specific fuel consumption? It is the amount of fuel consumed for developing 1 kilowatt of engine brake power. Okay. It is the mass flow rate of fuel for developing 1 kilowatt of brake power. That is your brake specific fuel consumption. What is the formula of BSFC? It is mass flow rate of fuel divided by brake power. And mass flow rate of fuel should be in what? Kg per hour. And brake power should be in what? Should be in kilowatt. Okay. So these were the important terms that we saw up until now. The last important terms that we have are your efficiencies, right? See, these two videos are all about the important terms. They are just to introduce these terms to you. Hopefully you will get a basic idea, but when we start solving these sums, you will get an even better idea of what is happening. Okay, so by now, air standard efficiency is the standard efficiencies of your Otto cycle, diesel cycle, and dual cycle. Okay, you know the eta 1 minus 1 upon r raised to gamma minus 1, that one, that those are your air standard efficiencies. Okay, you have direct three formulas for your three air standard efficiencies. The next efficiency is what? Indicated thermal efficiency. Okay, as the name suggests, indicated thermal efficiency is what? Indicated thermal efficiency is the ratio of indicated power to thermal power. What is indicated power? Indicated power is the amount of useful power developed inside the combustion chamber. What is thermal power? Thermal power is the amount of power produced due to the combustion of fuel, right? So what is indicated thermal efficiency? Indicated thermal efficiency is indicated power divided by thermal power. What do you understand by indicated thermal efficiency? See, indicated thermal efficiency explains to you कि whenever you are burning fuel, how much amount of that fuel is actually being converted into useful work. See, if your engine has very low indicated thermal efficiency, what does that mean? Ki you are burning a lot of fuel, but only some amount of that fuel is getting converted into useful power. So your indicated thermal efficiency should be as high as possible, right? That is the meaning of indicated thermal efficiency. Now, what is, I will first explain mechanical efficiency, then go to brake thermal efficiency. What is mechanical efficiency? Mechanical efficiency is the ratio of brake power to indicated power. What is brake power? Brake power is the final output power produced, final output power measured at the crankshaft. What is indicated power? Indicated power is the power produced inside the combustion chamber. And what is the difference between brake power and indicated power? The difference between brake power and indicated power is your frictional power. Frictional power is the amount of power which is lost when transmitting the power from your combustion chamber to your crankshaft. So mechanical efficiency is measuring how much amount of power is lost as frictional power. If your mechanical efficiency is 100%, what does it mean? It means that there are no frictional losses. So if your mechanical efficiency is low, it means that there are some amount of frictional losses, that you have to improve your engine. You have to add more amount of lubricant inside your engine to increase your mechanical efficiency, right? But if your mechanical efficiency is high, it means that all the engine parts are working smoothly. There is less amount of friction and less amount of power is being lost. And brake thermal efficiency. Brake thermal efficiency is kind of the overall efficiency of the engine. Okay. What is brake power? Brake power is the final output power which we are getting from the engine. And what is thermal power? Thermal power is the input power to the engine. What we are putting in form of fuel, right? We are putting in fuel. What is the amount of fuel given? What is the amount of energy given out by the fuel? That is your thermal power. And what is the final output power that we are getting from the engine? That is the brake power. So brake thermal efficiency is the overall engine efficiency. What is the output that we are getting from the engine, and divided what is the input we are going to the giving to the engine. So that is our brake thermal efficiency. Similarly, we have volumetric efficiency. What does volumetric efficiency mean? Volumetric efficiency is a measure of the breathing capacity of the engine. See what is happening inside your engine. Okay, see, this is your cylinder, this is your top dead center, this is your bottom dead center. Now when the piston is in your intake stroke, piston is moving from top dead center to bottom dead center, right? What do you expect? You expect that all this amount of volume should be filled up with the incoming air. Whatever air is coming into the engine, that air should fill up all this volume. What is this volume? This volume is your swept volume. This volume between top dead center and bottom dead center is your swept volume. Ideally, what should happen? All this volume should be filled up by incoming air. But what happens in an actual engine? What happens? Some amount of this volume, okay? Let us say this is my swept volume. In an actual engine, what happens? Only some amount of this volume is filled with incoming air. Only some amount of this is filled with fresh charge, and this amount of air has old charge of the previous cycle inside it. Okay, the previous cycle load gases get trapped inside. So the amount of fresh charge, the volume of fresh charge coming into the cylinder is less than the swept volume, right? And that is volumetric efficiency. Volumetric efficiency is doing what? Volumetric efficiency is a ratio of the actual mass of intake air, actual mass of the amount of air which came into the engine divided by the ideal mass of intake air. Ideal mass of intake air means how much amount of air should have come into the engine. Okay, through this derivation, after everything, you can also say that volumetric efficiency is what? It is actual volume of intake air divided by the swept volume. See, just what I explained right now. Ideally, what should happen? This entire swept volume should be filled up with incoming air. But what happens out of this? Some part, okay, some part is filled up with the old charge itself, what was used in the last combustion. Okay, so only this amount is left for your fresh charge. Okay, this amount is left for your fresh charge. So blue divided by blue plus yellow, blue divided by blue plus yellow is your volumetric efficiency. Okay, so it is a measure of the breathing capacity of the engine. Higher the volumetric efficiency, more will be the fresh charge coming into the engine. And more the amount of fresh charge coming into the engine, more will be the combustion and more will be the power produced. Okay. And the last thing that I want to tell you is this Sankey diagram. Okay. What is this Sankey diagram? This Sankey diagram is explaining how the energy flows inside of an engine. As I explained to you before, whatever amount of petrol you are putting into your engine or whatever amount of diesel you are putting into your engine, that is this power. This is what? This is your thermal power. This is your thermal power. This is your thermal power. Out of that thermal power, only some amount of power is useful power. That is written over here as motive power. We know that power as indicated power. Other all power is lost. It is lost to exhaust gases, it is lost to cooling, it is radiated out, there is some amount of noise. Other all power is lost and only some amount of power is useful power, that is indicated power. Out of this indicated power, again there are some frictional losses, and those are, that is your transmission losses, which is your frictional power. And the remaining final output power of the engine, that is your brake power. Okay, so this is what all the things that I explained to you, they are explained in a simple diagram. Every engine has its own Sankey diagram. Okay, through this Sankey diagram you can calculate the efficiency of the engine. The bigger this arrow, the better. More this power and more this power, the better. We want our brake power and indicated power to be more. We want our losses to be less. This is explained in this Sankey diagram. So Sankey diagram is a virtual representation of the flow of energy. Ki how energy is flowing in an internal combustion engine. That is represented through this Sankey diagram. Okay, so hopefully you have at least some basic understanding of the definitions, all the definitions that we have seen till now. Okay, so hopefully when we solve the sums you will get an even better idea, but my suggestion is to go through this presentation again and again, because these definitions are very much necessary for understanding whatever is going to happen in the next few lectures. Okay, in case of any doubts you can always ask me. Okay, no problems about that. Okay, thank you.